So I would like to remind you for a few things. So right now, if you have a warehouse like this one, we can assume the layout, the main system. We are focusing on trusses. Later, we will focus on frames, but right now we are focusing on trusses. So we have truss, and this truss is repeated at equal spacing, like this. So guys, from homework number 2 and homework number 1, you can right now able to calculate what are the dead load, life load, wind load, snow load on this truss. That's right. So if you have an existing building, or if you are trying to design a building mainly made from trusses, you can right now able to calculate or estimate the dead load values and life load values, wind load and snow load. Just to remind you, because there is few mistakes in the homework, please go back to the graded homework. You can find your mistake if you have any. The direction of dead load, life load, and the snow load are vertically downward. Vertically downward. Most of the time, this value and this value are half these values. And that makes sense. For wind load, guys, for wind load, because there are 2 or 3 students did it wrongly. Guys, when you are calculating QZ and then QH and then the applied pressure, this pressure is bound per square feet, still surface load. We need to convert this pressure or this P to concentrated load at each joint of the truss. And remember, this concentrated load not vertical or horizontal, it's perpendicular to the sloped direction. And it's a suction. Most of the time it's suction. We have concentrated load at each joint. How can I figure out these values? The calculated pressure P must be multiplied by A by S. Just to remind you, S is the spacing between main system. A is the spacing between purlins. So pressure times A times S, you can give you a concentrated load at each joint. Also, for the windward wall, we have line load. What you calculated here from pressure is surface load on this side of the warehouse. Surface load on the area. We need to concentrate the surface load to be only on one main system. So I need to multiply this pressure by distance S. So the uniform distributed load here must be pressure of the wind load times S. And we have suction on the leeward wall. This suction equal the calculated pressure that you did previously must be multiplied by S. And last meeting, we learned how to build this truss on RISA 2D. And how can I define this case of loading? And how can I make RISA 2D to do envelope combination to give you the final maximum combination? Does that make sense? I would like in my courses to start any design from scratch, from the logic sequences. If you decide to design any steel structure, you need first to start with layout, then loading, then analysis. And finally, it's not finally, but the next step is design. Anybody know what is the final step? Anybody knows what is the final step? After design, what you need else? What do you think? Build, approve? From a professional engineer, you have to pay money. So I'm looking for more money in the future. Anyway, no, I'm talking about the sequences for design. After design, you need to draw details, because your design is just calculations. Do you think the worker or the builder will use your calculations? I don't think so. The worker in the site, I think he needs drawings. So you need to use AutoCAD one more time to do or to draw details, more details about connections, about members, about all of this stuff. Anyway, we already learned a little bit about layout and loading and analysis using RISA 2D. And today I'm gonna start to design. Until this moment, I didn't answer this question. What is the size of this member? What is the shape? What is the size of this member? Do you remember first meeting in this course? I told you we have many shapes of the cross section for steel structures. Probably W shape, probably angles, probably channels, probably bisection. That's right. So what is the shape of the used member? And if you decide the shape, what is the size? Because we have different sizes for each member, for each cross section. So we need right now or today to design truss members. The next step after you design this member, we need to design this connection. If you are looking for any steel structure, this connection can be welded or can be bolted. So if it's bolted, how many bolts do you need? If it's welded, what is the size of this weld? All of these questions we need to answer starting from today until exam number 1. Any question? Any question? So it's important to understand what is the whole story. And then we are doing parts of this story. Today, I'm gonna start to design of trusses. Before also starting to design and showing these details, I would like to remind you or give you information about the different parts of the truss. This truss, we have different parts. The first part, this element and this element. What is the name? Columns. Columns. We have two columns. This column is starting from the foundation, and the foundation most of the time is footing, isolated footing. And you learned it before how to design isolated footing. And then we have columns starting from the foundation until this level. The same also on the other side. This column, most of the time, is W shape, wide flange, cross section, like this, most of the time. The second part of this truss is these members at the top and these members at the bottom. The top members can be called top chord. The bottom members can be called bottom chords. Most of the time, the top chord will be under compression. These members are under compression. You can find compression forces in these members. Do you remember structure analysis of trusses? The bottom chord, most of the time, is under tension. These members will be under tension with different values. For top chord and bottom chord, most of the time we are using double angle. This shape, double angle, 5 times 5 times 1/2. For example, this symbol means we or sometimes we write it like this: 2 angle 5 times 5 times 1/2. So the meaning of this symbol or this one, we have 2 angles back to back, like this. So the top chord and the bottom chord, most of the time, they are double angles, cross section. Then the vertical members and the inclined members can be called web of the truss. These members are 1 angle. For example, 5 times 5 times 1/2. This symbol means 1 angle only, like this. Does that make sense? I'm not sure they are under tension or compression or zero force member. They are variables. They are variables. I told you the bottom chord 99% under tension. The top chord 99% under compression. The web in between tension and compression, and probably zero force members also. Any questions so far? If you have any question, let me know. So, if you decided to design these members, we need mainly to understand how to design tension member and how to design compression member. Because members in the truss, one of them tension member or compression member. Do you think if you have double angle like this as a member extending in this side, do you think if you have tension will be the same behavior if you have compression? I need answer. Anybody can answer this question? Do you think if you have a steel member, if this member under the effect of tension will be the same behavior if this member under the effect of compression? No. Why? Okay, no. Why? What is the difference between this behavior and this behavior? We have a very important phenomenon. Do you know which is this phenomenon? You can write only one word. Thank you, Cody. Yeah, one word. Buckling. Buckling. Until this moment, you learned buckling. So buckling will be the only difference between tension and compression. And there is another difference. I will cover it probably today and the next week. No, compression will not bend. Compression will contract. But bend will happen if you have buckling. Okay, so we are talking about this term, buckling. Anyway, guys, so design of trusses. Today, I'm gonna start with design of tension member. Here is the truss. We finished the analysis of this truss. And right now, we can figure out the internal forces in each member. And I can tell you this force is tension or this force is compression. So we have tension members, we have compression members, and we need to design these members. By the way, for the members of the truss, probably your members are double angle, back to back, or these angles can be form or can be star shape. The angles can be connected by this shape sometimes, or single angle with an equal legs. This leg is not equal to this leg. We don't like this. Or equal angles, equal legs. This leg equal to this one. So this truss member most of the time is consisting of angles. You are talking about single angle or double angle. Can you see from this member? Double angle, we have two angles connected here by something called gusset plate. Okay? To figure out the tensile strength of any member, we have two limit states. We need to avoid yielding of the member, and we need to avoid rupture or fracture of the member. To figure out or to avoid yielding, the nominal strength of the member equal F yield time gross area of the cross section. If you would like to avoid rupture of the member, the nominal strength of the member equal F ultimate time area effective. So area gross area of the member, area effective called effective net area, F yield stress, F ultimate or tensile strength. Guys, I would like to remind you for something we covered before. I'm trying to give you update every time. We have something called strain curve for steel. Do you remember that? Like this. At the end of the linear relationship, we have here something called F yield. If you multiply this level of stress by area gross, you can figure out or you can find the nominal strength to avoid yielding. And we have another value here at the highest level of stress called F ultimate. This ultimate stress, if you multiply it by effective net area, you can get the nominal strength to avoid rupture. I have two questions here, and I'm looking for your question in this point. What do you mean by nominal strength? We understand this concept, nominal. Nominal, we need to multiply this term by something called a reduction factor. Do you remember phi? If you multiply phi by Pn, you can get the design ultimate strength. That makes sense? Do you remember in the concrete course, we have something called Mn and we have something called phi Mn. This one is the nominal, theoretically. This one is the design value. So the nominal value is Pn. This value to avoid yielding. This value to avoid rupture. If you would like to get the design value, you need to multiply Pn by phi. If you are talking about yielding failure, phi equal 0.9. If you are talking about rupture failure, phi equal 0.75. That makes sense? This is the first one. The second one, what do you mean by area gross and the effective net area? So your member will be connected to gusset plate by bolts. Can you see this picture here? At this location, what are you seeing here? Bolts. Yeah, we need to connect this member to this gusset plate and this member to this gusset plate. So we have bolts. Okay? If you have bolts, we will have holes in the member. If you have holes, do you think the cross section of the member will be the same at this location like here? Guys, do you think the cross section of the member will be the same at the location of the holes and any other location? Do you think? So we have at this location something called area gross, the total cross section of the member without considering any holes. But at the location of the holes, we have something called area net. That makes sense? That makes sense? So if you go back here, we have a term here called area gross without any balls. Because if you go back to this member, at this location, we have a member without any balls. That makes sense? But at this location, we have a member with balls. So I need to check this location and check this location. Okay? So if you would like to get the net area from gross area, you need to take the holes out from the cross section. What will happen if you have welded connection? If you are welding this member by this gusset plate by welding, do you think we have holes? Do you think we have holes in the member? No. If you would like to weld, we don't need any holes. So the net area will be the same like gross area. Any question for this point, guys? Do you have any question for this point? That makes sense? So I have a question. Probably from this comparison between case of bolts and the case of weld, what do you think? Which one is better to connect members, by welding or by bolts? What do you think? I believe welding will be better because you are not going to do holes, because holes in the member will reduce the cross section rather than or instead of area gross to be net area. Regardless the cost or the effectiveness of doing bolts or welding, because welding you are doing this on site, but bolts you can do holes in the shop or something like this. And also we have another advantage and disadvantage. One of them, this is a question for Brock. If you have rust or corrosion, both of them can be corroded, or you can expect rust, because this one is metal, this one is metal also. But if you would like to repair, if you would like to replace, can you understand? If you would like to replace the member, is it easy, or which one is more easy, to remove these bolts and put a new member, or remove this weld? Which one is easier? That makes sense. So at this point, bolts is better. Because to remove bolts, you need only to lose the washers and nuts. That's it. Remove the bolts, put new member, and tie these bolts one more time. But to remove a member from another member or from a gusset blade and you have weld, it's hard. It's very, very hard. You need to do more work. Okay, so anyway, it's not our topic, it's not our point, but I'm talking about specific point. Which case is better than to get the full benefit of the cross section welding? Okay, probably we have another disadvantage, but anyway, it's not our point right now. Let's start. Sometimes your holes and bolts are arranged parallel to each other, rows like this. 1 row, 2 rows, 3 rows, but these rows are parallel to each other. Sometimes these arrangements are staggered arrangement. Staggered, what do you mean by staggered? I mean we have rows, but these rows are staggered like this. So this arrangement can be called staggered arrangement. But the first arrangement, we have rows and we have columns. This one we have rows, but they are staggered. This column and another column and like this. So you need to figure out what is the arrangement or what is the assumption of the arrangement of the holes. Then I will assume probably we can expect fracture here. So what is the area net? Area net equal the gross area, the total area of the cross section, minus the area of this hole and the area of this hole. How can I figure out the area of the hole? We have most of the time will be given in the problem diameter of the bolt. Technical question. A technical question. Do you think if we have bolt with diameter, for example, half inch, and we have a steel plate, do you think the diameter of the hole will be half inch? We need to put this bolt in this hole. The diameter of the bolt is half inch. Do you think the diameter of the hole will be also half inch? I think no. It should be wider a little bit. Wider? Yeah, that makes sense. So the standard or the AISC code said, if you would like to look for the diameter of the hole, okay, use the diameter of the bolt, but add 1/16 inch. Okay, so most of the time, 100% in the problem, I will give you the diameter of the bolt. So you need to figure out first what is the diameter of the hole, equal diameter of the bolt plus 1/16. Then the diameter of the hole will be added to another 1/16 because you don't have perfect circle. This circle will not be perfect. Okay, so the final diameter that you need to subtract will be diameter of bolt plus 1/16 to get the diameter of the hole plus another 1/16 because you don't have a perfect circle. Okay, then this gusset plate or this plate has a thickness. What you did is you are getting this diameter, then you need to multiply it by this thickness to get this area. How can I get this diameter? This vertical distance equal diameter of bolt plus 1/16. This is the diameter of the hole. Another 1/16 because you don't have a perfect circle. Then this diameter multiplied by the thickness, you can get the subtracted area. If you have two holes in this line, you need to multiply it by 2. This is the reason why I put here summation. Probably we have 3. For example, if you have blade like this, and the arrangement of balls looks like this. Parallel to each other. Okay, I expect failure probably through this cross section. So I'm gonna subtract the gross area minus D hole, the D hole diameter of the hole equal D bolt plus 1/16. We need to add another 1/16 to the diameter of the hole time thickness, the thickness of the plate, but this is the hole, one hole for one hole. Diameter of the hole plus 1/16 times thickness only for one hole. How many holes do you have? We have 3, so I need to add 3 times, which is represented here by summation. Any question regarding this point? Guys, during the FE exam, you can expect question like this. During FE exam, you can expect question like this. We have plate 6" times 1/2 inch. And we have balls 7/8 diameter inch. And the arrangement of these balls looks like this. What is the value of area gross? What is the value of area net? Few questions like this in the FE exam. I'm not talking about PE, FE, piece of cake. So, what is the meaning of plate 6" times 1/2 inch? What does it mean? This plate in the real life has a thickness like this. So 6" is this length, 6". 1/2 inch is the thickness of this plate. If you multiply 6 times 1/2, you can get the gross area of this cross section, the gross area. If you would like to consider the holes, we can expect failure through this cross section, for example. So I need to subtract area gross minus what? First, the diameter of the bolt 7/8. Can you tell me what is the diameter of the hole? Equal diameter of the bolt plus 1/16. So what is the diameter? of the whole, 7/8 plus 1/16 equal 15/16 inch. So the diameter of the hole 15/16. I will add another 1/16. We don't have perfect circle. And this diameter of the hole will be multiplied by thickness. 1/2 thickness of the plate. But you are subtracting right now only one hole. How many holes do you have in this expected failure? How many holes? 2. So I need to add here 2 times. So if you put area gross 3 inch minus this number, you can get the area gross 2-inch square. So if you are talking about yielding of this member, we will use area gross. If you are talking about fracture or rupture of this member, we will use the area net. Any question? Thank you. Any question? These basics are very important. Please pay attention. Please pay attention. We are talking about something different than what we learned in concrete design. And the design of steel is more sensitive. Because if you have 1 millimeter, only 1 millimeter difference between the diameter of the hole and the diameter of the bolt will not work. Does that make sense? So it's very sensitive. Very sensitive. Okay. This is the first one if you have parallel holes like this. The other one, staggered arrangement. Let me explain it here. Staggered arrangement. The arrangement looks like this. We can expect failure through this cross section, probably, or we can expect failure through this cross section. The failure, I'm talking about rupture of this member. The rupture can happen through this cross section, including only 2 holes, or these holes in this vertical line, or including failure like this shape. So case number 1, case number 2. If you are talking about case number 1, it's normal. We have 2 holes. So area gross minus 2 times d hole plus 1/16 times thickness, I can get the area net. That makes sense. So this cross section, which is area gross, I will subtract the area of this hole and the area of this hole to figure out the area net. Any question regarding this point so far? or probably, or we have case 2. Your cross section looks like this one and this one plus this one plus this one, and I need to subtract 3 holes. So area net equal area gross minus 3, because we have 3 holes, time d hole plus 1/16 time thickness. But this inclined line and this inclined line will be the same like this vertical line. Which one is bigger, the inclined line or the vertical line? For another, in a different way, if you add this one plus this one will equal to this vertical one? No. So we need to add summation, another term here, summation s square divide 4g time t. What is the s? Spacing between bolts. What is the g? Gauge length between this row and this row. How many inclined line here? This line and this line, so we have 2. For example, if you have something like this, what is your expectation? We have 2 cases. Case number 1, failure like this. Case number 2, what else? Probably we have this failure. That's right. So we need to check case number 1 and the case number 2 by this way. So guys, if you have staggered, we have 2 cases. The first case, vertical failure, or something like this. If you have this inclined failure, we need to add this term summation s squared divide 4g. S is the spacing between bolts, and g is the gauge length between this row and this row and this row. So this is the meaning of area net. This is the meaning of area net. However, this one is talking about not area net. It's effective area net. What is the meaning of effective area net? Sometimes you have a member made from angle like this. Let me draw it here. This angle looks like this. And this angle is connected to a gusset plate here by bolts. Do you think the whole gusset, the whole member is connected perfectly to the gusset plate? No. Only this side of the member is connected to this gusset plate, but this free leg is not connected directly to the gusset plate. So we don't have efficient cross section. We will replace it by something called effective, because we expect something called shear leg. So to consider the shear lag, we will use effective area equal net area time a term called U. So to consider the effect of shear lag, we are going to use effective net area. One more time. Shear lag occurs when the tension force is not transferred simultaneously to all elements of the cross section. For example, this angle is connected to this gusset plate by this leg only, and the other leg is free, not connected. So we don't expect perfect transference or transmission of force. So we have to consider it by using effective area rather than net area. How can I use this? By using a term called U, which is shear lag factor. And this term U equal 1 minus X bar divide L. And I'm gonna explain what is the meaning of this term later, next week. Let's do an example here. Let's do the first example here. We have bar element 5" time 1/2 inch made from steel A572 grade 50 is used as a tension member. It is connected to a gusset plate with 6, 1, 2, 3, 4, 5, 6, 7, 8" diameter bolts. So the diameter of the bolt equal 7, 8". Can you calculate the gross net effective area? What is the meaning of bar of 5" time 1/2? This means this member is 5" width, 1/2 inch thickness. So the gross area will be 5 time 1/2 equal 2.5 inch. I'm sorry, 2.5 inch square, the area. We are looking for net. What is the arrangement of the bolts? Are they parallel or staggered? They are parallel. We can expect failure probably in this cross section. So the area net equal area gross minus. How many bolts in this expected failure? 2 bolts. So 2 times. What is the diameter of the hole? Equal diameter of the bolt plus 1/16. So 7/8 plus 1/16 equal 15 divide 16. So the whole 15 divide 16 plus another 1/16 time thickness of this blade 1/2. All of these terms multiplied by 2 because we have 2 holes. And the area gross 2.5. So the final answer for area net equal 2.5 minus 1.5 inch square. What is the value of area effective? Equal U time area net. U will be 1 time area net 1.5. So the effective area will be 1.5 inch square. I'm sorry, why you are using u equal 1? You said u equal 1 minus x bar divide L, but I forget to say something here. If the tension load is transmitted directly to each of the cross-section element by fasteners or wells, the value of u equal 1. What you mean? I mean we have this plate, 6-inch, I'm sorry, 5-inch time 1/2. And this plate is connected to a gusset plate by 6 bolts. Do you have any part from this plate or from this member is disconnected to this gusset plate? Remember, do you remember the case of an angle? If you have angle as a member, and this angle is connected to this gusset plate by these bolts. These bolts is connected between this leg only and this gusset plate. One leg and the gusset plate. Do you think the vertical element or the vertical leg is connected directly to this gusset plate? No. So area net equal U time, I'm sorry, area effective equal U time area net. And you have a value of U. Most of the time, this value smaller than 1, like 0.9, 0.85, 0.75, 0.8 sometimes. But if the whole element of the cross section is connected to the gusset plate, U equal 1. That makes sense? So we have here in this case plate or bar. This bar is connected directly to the gusset plate, so U equal 1. And the area effective will be the same like area net. Any question? Alan, you have a question. Why is it not 3 that you multiply with? For which one? I will cover this point later. Don't worry. Don't worry. I will cover it in more details later. Okay, let me explain example number 3. Example number 3. Calculate the gross and net area. Area gross and area net. We have plate. This plate with thickness equal 1 inch. This plate has a thickness equal 1 inch. First of all, what is the area gross? I believe the area gross will be this total height times this thickness, so you can get the area gross. What is the total height? 3 plus 5, 8 plus 8, 16 times 1 inch. So the area will be 16 inches square. Does that make sense? Here is the gross cross section. 16 is the total height. 1 inch is the thickness. So if you multiply 16 by 1, you can get 16 inches square. How can I get the area net? We have two expectations. The first one, probably, your failure will happen through this cross section. Probably. or your failure can be happen through this cross section. Let's see case number 1 and case number 2. Case 1. Area net equal area gross minus how many bolts here in this 1, 2 time. Don't forget d hole equal d bolt plus 1/16. So the diameter of the bolt 1 inch plus 1/16. So you have 17/16. So 17/16 plus another 1/16. Don't forget time the thickness. I can figure out the value of area net in this case. (14.875 inches square). Case number 2. This one. So area net equal area gross minus how many bolts do you have in this base? 3 bolts. Alan, how many bolts in this base? 3 bolts. Time. D hole 17/16 plus another 1/16 time thickness. Because we have inclined base, how many inclined do you have? 2. Time. S square divide 4G. Time thickness. Plus. So we have area gross minus this term plus this term. The value of thickness 1/2. The value of S, the value of G. What is the spacing between this bolt and the following bolt? What is the horizontal spacing? 3 inch. G is, yes.
You keep putting thickness is 1/2, but I believe it's 1.
I'm sorry. You are right. You are right. You are right. I did it here also. Oh. So the thickness is 1 inch. 1 inch and 1 inch. I believe this number will be different. Just a second. Yes, 13.75. I'm sorry. Thank you, Brock. Yeah, here you go. What is the value of G? G is the gauge length between this row and this row, 5 inch. So if you put S 3, G 5, and get your final answer, you can get the area net for this case. Let me do it. 9 divided times 2 plus 16 minus 3 times. This one will be 13.525. Which one is critical for you? Do you think case number 1 is critical or case number 2 is more critical? Case number 1 give you area net equal 13.75. Case number 2 give you area net equal 13.525. I believe case number 2 will be more critical. So I'm gonna consider this case with this area net. One of you will say, hey, Dr. Ayman, we can expect another failure like this. Yeah, I agree with you, case number 3. But believe me, case number 3 will give you more area net because you have only 1 bolt. Okay, so I'm trying to figure out any expectations about failure. Then I'm gonna calculate the area net for each case and the most critical case with the least value of area net. This area net will be used in design, and I'm gonna continue next week to go back to find the nominal strengths and the design strengths to figure out the final design of the member. But today we learned how to calculate the gross area and the net area. I will do more examples next week to cover this point in more detail.